Hello, welcome to another video. This is Mr. Campo, and today we're going to do part 2 of the linear equations, linear inequalities, and simultaneous equations lecture. So in our last video, we did changing the subject of the formula. So now we're going to do simultaneous equations, okay? And so let's dive into it, right? So let's see, simultaneous equations. So it's just a system of equations. You're going to have two variables, x and y. Usually it's just x and y, right? You can use any two variables, but it's usually x and y. And you're going to have two equations using both variables. So you're gonna need to find the values for the two variables to make the expressions true. And there are two methods to do this. You have the substitution method and the elimination method. I guess I should write method. Okay, elimination. And substitution. So with substitution, you're going to isolate one of the variables, and then take that new expression and plug it in the second equation. Okay. With elimination, as the number says, you're going to eliminate one of the variables. So the way to eliminate a variable, is by, if you have something like this, right? For example, this would be 0. So x will be eliminated, right? Let's say this is my equation, 2y plus y, and I have, I don't know, 2 and this 3. So if I combine them, right? If I add up these two equations, I'm going to get, this will become 0. So I cancel x. This would be 3x. And this would be 2 plus 3 equals to 5. So y equals to 5/3, right? And then we just take this and we plug it in one of these two equations to find y, right? So that's how you eliminate. Substitution. Let's see if I have an example for substitution. You just isolate, for example, let's see this one. X minus 2y equals to -3, and then 2x minus 3y equals to 2. Yeah, we can isolate this x, right? And this would become x equals to 2y minus 3, right? 2 times y minus 3. And then we can take this and plug it in here, right? Bring it here and find the value for y. And then after we find our y, we can just find our x using either equation. Again, with substitution method, you isolate the easiest one. This is the easiest one to isolate, in this case, x, right? And after you get that expression, you want to take that and plug it in the second equation. You don't want to plug it in the same equation, right? Because you're just going to get, it's going to go around in a loop. So you just plug it in the second equation, and then you solve for the other variable. And then after you get that, you can just go back and put it in either equation, and you should be able to find your missing values. So let's do some examples. From my lecture paper, this will be example 4, number 1. And I have 5x minus 3y equals to 20. And I have 2x plus 3y equals to 15. From this, we can see that we can eliminate y, right? If we combine these two equations, we can eliminate y easily. So how do you choose a method? You got to choose the one that's the most suitable for you at the moment with the given expression. you might find substitution better or elimination better. Right here, I find that elimination is faster because these two can be eliminated quickly. If I were to use substitution, it would require more steps. I would have to isolate, yeah, like an X or a Y, and that's going to require more steps. So again, just choose the one that you find um, the most suitable for you at the moment. So if I combine these two, I'm going to get 7x plus 0, right, equals to 35, right? Now I just divide by 7. And then Rx equals to 5. We're not finished yet, right? We found X, now we got to find Y. So you can choose either equation. You can choose either equation and just take this value and plug it in, either here or here, and you should be able to find Y, right? So let's see, I'm going to use, I don't know, my first equation, 5 times 5 minus 3y equals to 20. So this would be 25 minus 3y equals to 20. Then I subtract 25 from both sides. I'm gonna need more space. Maybe I'm gonna do it here. Okay, I'm gonna do it up here, then I'm gonna bring it up down here. This would be 0 minus 3y equals to minus 5, right? All right, now I'm gonna divide by -3. I'm actually gonna do it here. If I divide by -3, I'm gonna get y equals to -5 divided by -3, which is just 5/3. And that's it. Those will be the answers for uh, this system of equations. Okay, let's do another example. Example 2. Well, we did it before. We just found one value. Let's see. Yeah, this one. We didn't do it actually. We did it. I showed it. I used it to show you how you can use the elimination. I'm sorry, substitution method. So let's see. When I solved this, I used elimination, but let me do it by using substitution, and I should get the same answer. Equals to 2. So from before, we have that 2x equals to 2y minus 3, right? So I'm going to take that and I'm going to plug it in this equation. So I'm going to get 2 times x, which is 2y minus 3, right? Minus 3y equals to 2. Let's see, from using elimination, I got y equals to 8 and x equals to 13. That was from using elimination, so I'm going to use substitution and I should get the same answer, right? So we got 2 times 2y equals to 4y, 2 times -3 equals -6, minus 3y equals to 2. 4y minus 3y is just y, right? And then this -6, I can add 6 to both sides. And this becomes 0, right? So these two became 1, right? This one. And this, I'm gonna add 6 to this -6 to cancel it. And then I'm gonna send it to this side, right? And I get 8. And indeed, right? Y equals to 8, just like this one. And then if I use, I'm gonna use the first equation. It should work out with either equation, right? Because I'm using this method to solve them. So let me use the second one. So I have y equals to 8. Let me find x. 2x minus 3 times 8 equals to 2. So 2x minus 24, right? Equals to 2. I'm going to add 24 to both sides. And then I get 2x. This is 0, 26 And then x, 26 divided by 2, 13, right? Okay, and that's it. You see how I got the same answers? This I did from my notes using elimination, the elimination method. Oh, and this one is using substitution. So I got the same answers doing it in two different ways. Okay, let's do one more. Example 3, 2x plus 3y equals to 21, 5x plus 2y, 2x plus 3y equals to 21, 5x plus 2y equals to 3. Okay, so let's see, what can we do? Okay, in my lecture notes, I did substitution. And I got, let's see, x equals to -3 and y equals to 9. So let's see if I get the same, right? I should get the same. So this was using substitution. So I'm going to use elimination. So to eliminate, sometimes it's not so straightforward, right? You cannot just combine them and eliminate. So you have to multiply the whole expression by a number, which is going to help you eliminate one of the variables when you combine it with the other equation. So let's see, if I multiply, I can get this or this, I can get this one to 10 and this one, I can make it a -10, right? So if I multiply, let me erase this real quick. If I multiply all of this by 5, and that means I have to multiply every single element in the expression. And I multiply this by -2, I'm going to get a +10 here and a -10 here, right? And when I combine those two, -10 and +10, x will become 0, right? So let's see, this would be 10x, right? 5 times 2x. 5 times 3y will be 15y. And 5 times 21, let me do it real quick. 105. And then this would be -10x, right? This will be -4y. Right, -2 and 2y is -4y, and then we have -6. So now I'll go ahead and combine these two equations. This becomes 0. This becomes 15 minus 4y, 15y minus 4y equals to 11y. And this would be 99, right? 105 minus 6. And now we're going to divide 99 by 11. 99 divided by 11 equals to 9, right? So this y equals to 99 divided by 11 equals to 21. So this would be 2x plus 27 equals to 21, right? Then I subtract 27. All right, so that'll be 2x plus 0 equals to -6. And then x equals to -6 divided by 2, and that is -3. And then I got the same answer. Okay, you see I got the same answers using elimination as I did when I used substitution. All right, cool. All right, So that's it for systems of equations. Now we're gonna jump into some word problems, okay? Word problems. Now, many people encounter or find actually word problems difficult. And I understand. I think it's just a matter of getting used to them. The more you do them, the more you get used to them. So now I don't want to type all of this because it's going to be a lot. Let me bring it up. Oh, I know what I can do. I think I should be able to copy and paste. Let's see. Let's give it a try. I don't think you can see what I'm doing right now, but I'm accessing my files. And let me move my camera. I want to pull up this file. I'm going to copy and paste it and then bring it over to copy it from my file and then paste it on the whiteboard. This is linear equations, quadratic equations, week 3. Oh, week 1. Oh, this one. Oh, that's not it. I'm gonna have to edit this. This is lecture 1. Oh, this is lecture 1. That's why. Okay, found it. Let's see if I can do this. Did it work? Rectangle is 6 centimeters longer than it is wide. Find its dimensions. Okay, so let's get into it. A rectangle is 6 centimeters longer than it is wide. Find its dimensions if its perimeter is 64 centimeters. All right, so let's use my shapes here. Nice. So we have width here. This is the width, and this is the length. Length. And it says that 6 centimeters longer than it is wide. So it'll be the width plus 6, right? The length would be the width plus 6. Okay. And then there's find its dimensions if its perimeter is 64 centimeters. So the perimeter is going to be the summation, right, of all the sides. All of these, you add them up. So we have 2y plus 2 of these, right? So it'll be 2 times y plus 6. And it says that this equals to 64. So we can find W, and after we find W, we add 6, and then that'll be the length. So it'll be 2W plus 12 equals to 64. And then this will be 4W. And then I can subtract 12, right, from both sides. And that's going to give me 52. Okay, and then I can divide by 4. And that'll be 52 divided by 4 equals to 13. So the width is 13. So the length would be just 13 plus 6, right? 19. Okay. So let's just write it here. Width 13, length 19. And that's it, right? Pretty simple. Okay. Next, let me try to do the same. I'll copy and paste, and hopefully it works. Oh yeah, it is working. I can use this. Nice. Now, if it involves integrals, oh man, I don't know if it's gonna work. Maybe I can, I gotta figure out. Okay, the result when a certain integer. So we can let that certain integer be a. No, a would be a certain integer, right? And it says that the result when a certain integer, let's say a, is added to 5. So we add this to 5 and then divided by 5. It says the result when a certain integer added to 5 is divided by 5 is more than the result when the same integer is subtracted from 6. So we subtracted from 6. This integer, we subtracted from 6. Is divided by 9. What is the smallest value that the integer can be? Well, the result when a certain integer added to 5 is divided by 5 is more than the result when the same integer is subtracted from 6 is divided by 9. Okay? So we're subtracting the same integer from 6 and we divide it by 9, and this will be less or this will be more. So we just go ahead and solve this and find the value for a. So if you follow the steps, this would be, we'll cross multiply, and then we get 9 times 5 is 45 plus 9 times a, and then we get 6 times 5 is 30 minus 5a. Okay, now we want to isolate our variables, so we can do add 5 here and then subtract. This would be 0, this would be 14a, this would be 0, and this would be negative 15, right? Okay, and then we divide by 14 and we get a is greater than negative 15 divided by 14. So this would be negative 15 divided by 14, negative 1.0714. Okay, let's do it here. Greater than negative 1.0714. And it says, what's the smallest value that the integer can be? So if we do a number line, right? And this is negative 1.0714. And then, well, around here, we have negative 1, right? And then it says that a is going to be greater than this. Okay. So why am I drawing number 1 here? Because this is not an integer, right? But the next one, based on the condition, right? A is greater than this number. The next integer will be negative 1. Negative 2 would be around here, right? You know, so this is negative 1. It's a little smaller than negative 1. Remember, you go to the left, your number is becoming smaller, even though it's like negative 1.0714. It's actually smaller than negative 1, right? Because this one is a little bit to the left. a little more to the left than -1. And remember, that way small numbers to the right is big numbers. So if our integer, our certain integer has to be greater than this, right? And the next integer is -1. So that'll be it, right? The smallest integer would be -1. So in other words, this integer, this inequality can be changed to this, right? The certain integer can be greater than or equal to -1. All right, that's the smallest integer that this can be. All right. Okay, let's take a look at another one. A firm has as many junior workers as 5 times, I'm sorry, 5 times as many junior workers as senior workers. The weekly pay for a senior is 220 and a junior is 160. Write a system of equations and solve and find how many of them are employed if the total weekly wage bill is 15,300. Should be 15,000. All right. So let's see. So you want to use two variables, right? I'm going to let my x variable equal to a number of senior workers. And my y equals my number of juniors. And I'm going to make two equations, right? So it says that they have 5 times as many junior workers as senior workers. So in that case, the total number of workers, right? If I take 5 times the number of seniors minus the number of juniors, it should equal 0, right? Because this should be equal, 5x equals to y. It says they have 5 times as many senior workers as they have juniors. They have 5 times as many junior workers as they have seniors. All right, so we have to take the number for seniors, and we have to multiply by 5 to get the same number of the same number, which is the number equivalent to the number of juniors executives. Now it says that and now they tell us that why is it doing this? Seniors make 220 per week, and a junior makes 160. And the total weekly bill is 15,300. So now we can use this system of equations to solve for x and y. So what I can do is I can multiply by, well, I can use isolation, I can use substitution, right? I can isolate y, right? And y equals to 5x, right? Or x equals to y divided by 5. And then we can take it and plug it in here, right? So we have times 5x equals to 15,300. So we're gonna get 160 by times 5, 800. So we had 220x plus 800x equals to 15,300. As this would be 1,020. 1,020x equals to 15,300. Then we divide by 1,020. And that should be 15,300 divided by 1,020, 15. So we have 15 seniors, right? And it says that we have 5 times as many juniors, right? 5 times as many juniors. So number of juniors, right? Y equals 5 times 15, which is 75. Okay. And that's it. That's how we solve this equation. All right. Okay, let's move on. A publisher for a new, so let me just go back. So just to clarify, junior 75, seniors 15, okay? Okay. Hold on. Make this. Okay. Next, a publisher for a new novel calculates at fixed costs, overheads, advances, promotion, typesetting, copy editing, etc. To have it published are 55,000. So before I dive into this, you gotta remember this: profits for a company equals how much they make per sale in total sales minus the costs that they have. Now for costs, we're gonna have variable and fixed. Okay, so variable would be the number of units they sell, because it varies, and fixed would be rent, phone bills, internet bills, things that they have to pay no matter how many units they sell. So when we have, you want to figure out the break-even point, this one right here. The revenue equals the cost. So there will be no profit, right? If these two are the same, the profit will be 0. And that's called breaking even. So we have to set up, we have to find an equation for the revenue, and we have to find an equation for the cost. And then we set it equal to 0, and then we solve for x. And that x, the value for x is going to tell us how many units, at how many units we will be breaking even. So let's see. So it says a publisher for novel calculates at fixed costs. So for costs, let's see, we have fixed costs. These are 55,000. And variable costs are $2 per copy produced. And let it X be the number of copies, okay? Number of copies produced and sold. All right. If the novel is to be sold to distributors for $12 per copy, so revenue is going to be $12 per copy, right? Find the break-even point. So that's going to happen when profit equals to 0, and then I have my revenue being 12x minus the costs minus 55,000 minus 2x. So it'll be negative, and then I apply it to the whole expression, right? So I get 12x minus 2 equals to 10x minus 55,000. And now I just have to isolate x, right? So I send this 55,000 to the other side, and I divide it by 10. So x equals to, this will be positive, so it'll be 55,000 divided by 10. So you just cancel 1 0, and then we get 5,500. All right, so add 5,500 copies. This publisher will be breaking even, okay? That's it. So again, profit equals to revenue minus costs. For costs, you have variable costs and fixed costs. And then you have to, they'll give them to you. They'll tell you the fixed ones, and then the variable costs are usually have to do with the number of copies you make, how much it costs to make one copy. And then you plug them in the equation, make sure you distribute the negative onto both numbers. And then like I did here, and then just combine them, right? Revenue minus the cost. And then you simplify that, and they're usually going to ask you find the break-even point. So you set it equal to 0 and you solve for X. And that's it. All right, that's it for part 2. Thank you very much for watching. Don't forget to do the homework. If you are one of my students, the homework is from the learning guide. 0-2 and 0-7, all the exercises. If you have any questions about any of the exercises, you can send me a message. Okay, cool. Thank you very much for watching this video. If you liked the video, don't forget to subscribe. And if you have any questions and you're not my student, you can drop the question in the comments section. Bye-bye, take care, and stay safe.